All right, next question.
Sir,
Mhm. Go
will
ahead.
the subchapter of least squares and derivative will be on the exam?
What derivative?
Least squares.
Least squares? No.
Okay, thank you.
Least squares versus least square. I think that's 3/7 or something. Least square. No.
Sir, but on the book, least squares is 3.4.
Oh, 3.4. No, it won't be on the test.
Okay, thank you, sir.
In fact, it's never be on the material. Least square. Okay. Questions?
How about computing errors with limits?
Computing errors in
Limits, the one with epsilon.
All right. So yeah, there are two, say two, not two notions of errors. They are the same thing, but we have in the two contexts. You have errors in here, 2.9, and also in before limit here, rigorous study of limit. There's errors here. Okay, so which one?
The rigorous study of limits.
Rigorous studies of limits. All right. Oh, don't have to move this out. Let's go to the OneNote. So this based on the subsection of um, limits as estimation of error. Okay. Uh, should tells you about this one a little bit. Just remind you before we got into the problems. All right. What we say about this one. Okay, we say that the limit of f of x as x approaching a is L. That means uh, the value of f near L is near L uh, small if uh, this value is small also, right? So the thing here, we need to estimate what does it mean to be small? How small? Okay, so that's if we want this to be small, more, say smaller than one, and what should be x minus a. So this is what we mean by how small. If say small x minus a should be, or 1/2, same questions, say 1/4, same questions. So usually the problem is estimating this one. Okay, so less than one. So this number, we need to determine this one. Find this delta. Okay, so given this one, find x minus a less than what? Okay, so that means by this approximations, as error estimations. Okay, let's see a problem example. Say if we have just a square root. Okay, so this only works for x positive. Okay, let's say um, here. So square root is here. Say at 1. So you're measuring something here at 1 using this one. So 1 is the ideal measure. So somehow this one here, you always miss something by some little thing. For example, y1, that's because that's easy to compute. You can choose also 2 or 4 or whatever the number, any positive, not negative number. Okay. And so you would like to have this, you say 1/8. Okay, so the question is, what should be this one here to ensure that your measurement of the square root has error less than 1/8. Okay, so this is the rule of the functions of the measurement. So say this is rule of measurement. Sorry. This measurement. So you measure near 1. So you would like to have your measurement here. So this is your objective. Your measurement is less than 1/8, say the error. So the error is to make the error less than 1/8. Okay, so the question is now, what should be the error for this one? You see, the ideal x measurement should be 1. That's the ideal. But you're bound to have errors. So errors. So that's the errors. The thing is, what should be the maximum error here? That's the error. The error estimate. Okay. All right. So let's do this. Let's work. One here is you cannot get exactly 1, so you dismiss this 0. So that it will implies, just say, so find this delta. Okay, so how to do this one? Let's work backward. What do you mean work backward? Well, let's start from the square root. Okay, so how to do this one here? Somehow you have to transform this into something here times x minus 1. Okay, and if you assume this is less than delta, then this will be something here. Okay. All right, so the thing here is figure out a way how to transform this into this one. So to make x minus 1 appears. Well, one way to do this is, for example, let's multiply by this one. So this magician's trick. Okay, so then this gives you what here? This is a minus b times a plus b. So you get a squared minus b squared. Get x, sorry. Okay. All right, so then less than, okay. Here, to make it bigger, that means you have to make the numerator bigger, or you make the denominator smaller. All right, and because the top is already x minus 1, so you don't want to change that one. So instead, we make the denominator smaller. All right, so this is square root is positive. Okay, so of course, square root of x plus 1 is bigger than 1. So replace this by just 1. There we go. Okay, and you would like to have this less than 1/8. What should be the delta? Yeah, it's the same thing. Because you see, you want x minus 1 less than delta. Here you ended up x minus 1 less than 1/8. So what should be the delta? Well, that's the same thing here. So you choose delta equals 1/8. So delta in it is, if you're not writing this carefully, then it looks like the same. All right. Question about this particular example. So in fact, you see from this process, it doesn't matter it is 1/8 or 1/4 or 1/1000, you will get the delta is the same as the thing that we have in the beginning. Okay. Of course, because the process here is just 1 here. We replace it by 1, so it doesn't change anything. Okay.
Can you show us one more example where it's not the same, where the delta is not the
All
same
right.
as
So
the...
let's do some simple thing. Actually, same delta, same as the epsilon thing is one rare thing. So let's do some more example. F of x is, say, your measurement. Oh no, just do this one. 3 minus 5x plus 1. That's your measurement. So then you would like to measure around say around 1. Right? So around 1 f of x going to be uh, 1. Okay, so that f of 1 minus 2 have some error. Okay, have some error. So because we'll do this in general, so have some error. This means that measurement of at 1 measurement of f has so the question is, what should be the measurement of x near 1? Questions. What should be? So find this out. So what you need to find is error here, which implies fx f of x plus 2. Okay. Less than. Okay. So given this, find delta. Okay. So we work backward. Here. Now become plus 2. Is it clear why plus 2? Not minus 2.
So that's good.
There, that's minus 2. All right, so let's rewrite this. What is f of x? F of x is 3 minus. Okay, so let's simplify this. And this become 5 also. So the idea is how to make x minus 1 appear in some as some part of this one. All right, so in this case, you get this 5. You can take 5 out. Of course, this is same as this one. Because they're all the same thing, and you would like to have this. Okay, so the question is, what should be so this is delta. So you can figure out from here 5 times delta less than epsilon less than so you make a comparison here. Okay, yes, because from here you get that delta is okay, so you choose here Okay. So in this case, this makes sense in the, if you look at this picture, this is the slope 5 at 1. Say this is 1. This is 5. So if you make errors in this thing, okay, you would find the delta is smaller. Smaller than what? Is by a factor of 5, because this because of the slope is 5. So you see this is getting smaller here. There. That's your epsilon. And sorry, that's your delta. How to find delta here? By this geometric. What does mean geometrically? Okay. All right. For this estimations, actually what I given you as an example, the in class a few weeks ago, of course, there's a significantly more difficult than this one. And for exam, we won't go further than linear thing. So this is linear, or square root will that you will have the same delta, same as epsilon. Okay, questions for this example? Okay, so for linear things, this 5 comes from the slope. What's 3 minus, sorry, 3 minus. Oh, sorry. Our slope is actually 3 minus 5x, sorry. Not this one, not this figure. So the picture, I see, okay. So say picture looks like this one. Okay. So when S is F1 is -2. All right. So it should be, all right. So when you make this error here, measurement, you'd find the what is should be the uh, this is epsilon. Okay. All right. So let's see example. More questions? More questions?
I think it's pretty clear, sir.
Clear? All right. All right. So, question about other topics? No more? Then, if not, then we'll stop here our sessions. If you have more questions, just ask in the on Teams. I will write something, explanation, something, explain things.
Okay, sir. Understood.
All right, good. Will I'm still looking for the some sample exam from the online thing, but I haven't found uh, any open for you at this moment. So I'll ask the coordinator again of the sample exam. All right. In the meantime, we're going to stop the video. Stop.